it's Elizabeth Richmond, and my physics topic is unit conversions. While this physics topic may seem like one of the easiest, it is not just a topic to blow off and think of as so. Unit conversions is arguably one of the most important topics in physics to master. Not being able to properly convert units can lead to fatal mistakes, as seen in later examples. But first, why do we have to make unit conversions in the first place? Whose bright idea was it to make units that differ that can cause confusion among professionals, scientists, college students, and eager bakers alike? To make a long story short, units of measurements are all different because communities, countries, and cultures all had different ways of measuring different things that were important to them. Some places determined amounts of measurements to be the length of the size of their ruler's body parts, or on specific rods that were kept in public places or temples that everyone could see. Measurements on weight and volume were dependent on a community's supplies. They were not always the easiest to replicate among their own citizens, let alone other people from other places. Time could often be measured by using sundials, hourglasses, and water clocks, but not all of these methods were very reliable, let alone easy to replicate. It wasn't until the 1790s that there was an international standard for a unit. This unit would be the meter, and it was used to represent length. It still is. It was established by the French Academy of the Sciences. This definition has evolved a few times since then, and the current definition reads as such. The meter is the path traveled by light in a vacuum during a time interval of 1 over 299,792,458ths of a second. Other units are also determined by meters. For example, 1 inch equals 2.54 centimeters. There are standard units for 7 measurements, and they are as follows. Meter for length, second for time, kilogram for mass, ampere for electric current, Kelvin for temperature, mole for amount of substance, and candela for luminous intensity. Every other unit or measurement is derived from these base units. Here's a few examples of what I mean. For our first example problem, let's examine a shelf. A shelf is 21.5 inches wide. How wide is it in centimeters? First, write the 21.5 and put it over 1. Multiply this by the equivalent of inches to centimeters. It is important that you align the same units to be catty-corner to each other so that when multiplying across, the same units cancel out. So then you'll multiply across. 21.5 inches times 2.54 centimeters over 1 times 1 inch. This leaves you with 54.61 centimeters times inches divided by 1 inch. Now, you'll cancel out the corresponding units, inches, and you are left with 54.61 centimeters. So let's look at some of these group problems together. So how I'm going to do this is that we're going to work through them together, but I'm not going to provide the answer until the very end of the video. So that way, if you still need more time to work, I won't spoil your work with my answer. So let's look at number 1 first. Convert 188 kilometers into inches. So I've already got this one written down. So we're going to start with 188 kilometers, and just like the first, we're going to put it over 1. And the conversion we're going to do next is we're going to do the equivalent to miles. So we have 1 kilometer on the bottom, so they're catty-corner, and then 0.6214 miles over the kilometers. Next, we're going to take miles to feet. So in every 1 mile, there's 5,280 feet. Okay, once again, miles catty-corner, and we're looking for inches. This is supposed to be an inch. So in every 1 foot, there's 12 inches, as you know. So we're going to multiply this across. 188 times 0.6214 miles times 5,280 feet times 12 inches. And then we get the 1 kilometer, 1 mile, 1 foot. So now let's cross off the units with the kilometers, miles, feet, and then we're left with inches. So once you multiply that all across, you're going to have inches here, and what number are we looking for? Like I mentioned earlier, sometimes the unit conversions, making mistakes, can make fatal mistakes. So let's take a look at number 7, and while the mistake is not fatal, it did cost NASA a couple $1 million. So on September 23rd, 1999, NASA lost the $125 million Mars Climate Orbiter spacecraft after a 286-day journey to Mars. Miscalculations due to the use of English units instead of metric units apparently set the craft slowly off course, 60 miles in all. Thrusters used to help point the spacecraft had, over the course of months, been fired incorrectly because data used to control the wheels were calculated in incorrect units. Lockheed Martin, which was performing the calculations, was sending thruster data in English units, pounds, to NASA, while NASA's navigation team was expecting metric units and newtons. A solid rocket booster is ordered with a specification that it is to produce a total of 25 million pounds of thrust. So an intern accidentally writes this down as 25 million newtons. How would this be in pounds if 1 pound equals 4.5 newtons? So let's take this over to the notebook. So the intern writes down 25 million newtons, but they're expecting pounds. So we have to do a quick conversion. So we get the 25 million newtons over 1, and then we want to multiply this with the equivalent. So for every 1 pound, there are 4.5 newtons. And since we're looking for pounds, this is the last one we'll have to the right. And to make these conversions, make sure that the units are lining up, newtons, newtons. So it'll be 25 million times 1 divided by 4.5. So the answer will be seen at the end of the video. Alright, so we have time for one more problem, so let's look at number 13. In ancient Rome, volumes were measured in a unit known as the conguus, plural congi. I'm sorry if I pronounced this wrong. 1 conguus is equivalent to 0.92 American gallons. As an archaeologist, you discover a buried hoard of Roman wine in the ruins of Pompeii, a total of 10.4 congi. What is this volume in cubic centimeters? Alright, so we find 10.4 congi. So let's place that over 1. Oh, I put that line really low. And an equivalent for a congi in the problem, we found that 1 conguus was equal to 0.92 American gallons. And then via a conversion chart, we know that 1 gallon is equal to 231 inches cubed. But we're still looking for cubic centimeters, so 1 inch cubed is equal to 16.387 centimeters cubed. And that's the last one we're trying to find. So if we line up our units, cross out the conguus, gallons, inches cubed, and we're left with centimeters cubed, so that's what we want to find. So when we multiply this all out, we're going to want to find 10.4 times 0.92 times 231 times 16.387 to get our blank centimeters cubed. And now that we are at the end of the video, I wanted to show you our final answers for the 3 problems we went over for today. For the first problem, we came out with 7,402,000 inches. For problem number 8, we have 5.5 times 10 to the 6th pounds. And for number 13, it comes out to 36,220 centimeters cubed. Thank you so much for learning with me today. I hope you enjoyed, and if you have any feedback, please comment below. Thank you, have a great day.